Our project is about detecting DDoS attacks using machine learning techniques. We are capable of detecting two main types of attacks. One of them is the exploitation attacks. In this attack model, the attacker would use vulnerable systems across different networks to send malicious traffic toward the victim network, and this way they can exhaust resources on victim machines. UDP or TCP flooding attacks are examples of this type of attack. Another type of attack is the reflection attack. Here is an example of DNS reflection. Attacker would send multiple spoofed requests with the source IP set to the victim machine IP. And the DNS resolvers will respond to the request with multiple times larger payloads. And the destination of these responses would be the victim machine. So this is how we can detect these attacks at the victim network. There is a capture server which captured all the network traffic in form of PCAP files. The captured data was transformed to traffic flow statistics using CIC flowmeter in the CIC DDoS dataset. And these flow features, along with the labels, were used for training the neural network. So with the new traffic traces, if you feed the neural network with the extracted flow features, it can detect whether the flow belongs to attacked or benign traffic. This is the structure for the binary classifier model. As you can see, we have an input of 28 features, and the output is simply two classes, either benign or malicious. We use only 3 hidden layers with size 64, and we selected 28 features that have the highest influence on the classification accuracy. We also did proper pre-processing to normalize the feature values. In addition, we built a categorical classifier that tries to distinguish the type of attack among the 13 different DDoS classes. And the network architecture is similar to the binary classifier, but the output layer size is increased. In order to evaluate binary classifiers, we present three metrics, which are precision, recall, and F1 score. Our results demonstrate an improvement over the current state-of-the-art models, and we have included the source code for reproducing the reference paper results. Please note that you may have to restrict yourself to 1 million entry per attack because of the memory limitations. These are the true positive, false negative, and true negative for the binary classifier model. We have to mention that in DDoS attacks, allowing some malicious packets to pass won't be a major problem, so it's more important not to wrongfully block the benign traffic. For the category classifier, we didn't have a reference to compare to, but our accuracy is now around 62%, and the confusion matrix is displayed in this slide. The problem is that the dataset is not equally distributed, and that's why some attacks appear more than the others. So in conclusion, we managed to build the DDoS attack detection model. The next step is to improve the results for the categorical model, and also we will try to determine the influence of each feature to filter out any redundancies. A final milestone would be to integrate this model in real traffic. Finally, we present the references, the source code repository, and our contacts for any inquiries.